All right, hello mathematicians. This is practice page 3-6. This had to do with multiplying fractions and mixed numbers. Just to quickly review how to turn, in order to multiply, so say I have 1.5 times, we'll say 3/4. So 1.5 times 3/4. I have a mixed number and a fraction. I can't multiply, these are like two separate parts. So I can't multiply them one at a time because that wouldn't be the whole value. So I need to make this into a whole fraction like this. So the way that we do that is we have to convert it from the mixed number into the improper fraction. So the quick way to do that is to go around the fraction. The strategy for this is you do divisor times the whole number. So not divisor. You do the denominator times the whole number plus the numerator. So 2 times 1 is 2 plus 1 is 3. So 1.5 is the same as 3/2. So 3/2 times 3/4. Now we can multiply correctly. 3 times 3 is 9. 2 times 4 is 8. To put it in its final form, we'll convert this to a mixed number. 8 goes into 9 one time, and we have 1/8 left over, just as a general review. So looking at our problems here, I showed my work underneath. So 2/3 times 2 and 1/5, I went around the fraction, or I said, okay, so there's 2 wholes, so that's 2 5/5, and then I have 1 extra part here, so that's 11/5. And then we always look to see if we can simplify before we multiply. Here we could not, so we just multiplied across, got 22/15, and then converted that into our mixed number. So we say, okay, how many wholes do we have? Well, 15 can go into 22 once, and then how many parts do we have left over of those 15ths? Looking at number 2, we had to convert this first value, which gave us 25/6. We can't simplify, so we multiply across. I got 25/24. That is an improper fraction. 24 can go into 25 one time. I'm working with 24ths, so that stays the same. The difference between 24 and 25 is 1, so I had 1 piece left. 5/6 times 2 and 2/5 is the same as 5/6 times 12/5. I simplified to multiply, so I made an x with my eyes. 12 and 6. 12 is a multiple of 6, so I can divide them both by 6. And then when I multiplied across, I got 10/5. Remember, fractions are just like a division problem. So you could say, how many times does 5 go into 10? Or you could say, what's 10 divided by 5? 2. Over here, we converted 4.5 into 9/2. 9/2 times 1/2 equals 9/4, turning that into a mixed number is 2 and 1/4, which makes sense because if you did, so that this right here is saying 1/2 of 4.5 is 2 and 1/4. If we did 2 and 1/4 plus 2 and 1/4, we would get 4.5. So you could check your answer. Here we have 5/7 times 1 and 3/5, which is the same as 5/7 times 8/5. I made an x with my eyes and saw I can simplify my 5s because they can be divided by 5 and give me 1, which gave me 8/7. 7 goes into 8 one time, and I have 1 piece left over, 1 and 1/7. This one was kind of interesting because once I converted 2.5 into an improper fraction, and I simplified, both of my values, so this numerator, this denominator, this numerator, this denominator, could be divided by themselves, which gave me 1/1 times 1/1, which just equals 1. 1 divided by 1 is 1, or 1 could go into 1 one time. So our answer is 1. 1 and 1/3 times 9/10 is the same as 4/3 times 9/10. Made an x with my eyes, I simplified, and then I multiplied and got 6/5, which equals 1 and 1/5. Last for our top problems, 4 and 3/4 equals 19/4 times 1/3. I looked, I could not simplify, so I had to just multiply across. 19 twelfths, 12 goes into 19 one time, and I have 7 twelfths left over. You'll see down here that I cubed, circled the numbers, underlined the question, boxed keywords, wrote an equation, and solved my word problems. So the first one was a jewelry box is a rectangle with a length of 5 1/4 inches and a width of 3 1/2 inches. What is the area of the bottom of the jewelry box? You have to square your area. So make sure that was a joke. You're allowed to laugh. Cue laughing. So I had to make sure that on my label, which was inches, I put square. So I was multiplying my formula for area is area equals length times width. I have my length and my width. So 5 1/4 times 3 1/2. I converted those into 21/4 times 7/2. I looked and I could not simplify, unfortunately. So I got this gross looking number of 140, well, no offense number, but kind of gross looking number. 147/8. Remember, fractions are just division problems. So I did 147 divided by 8. I got a remainder, but I can't just ignore this amount because we're measuring. I have to be exact when I'm measuring. So that means I had 3/8 left. So my answer is 18 3/8. Number 10, the carrot pieces that ended up in the casserole were 1 3/4 times the number of celery pieces. I'm sorry, this is such a silly problem to me. Who counts the amount of pieces that they put in a casserole? No, whatever. Anyways, 1 3/4 times the number of celery pieces. If there were 32 celery pieces, how many carrot pieces were there? Okay, so we know that this is the number of carrot pieces is 1 3/4 times more. So there's more carrot pieces. So in order for my answer to be reasonable when I solve it, the number of carrot pieces has to be larger than 32. So I'm doing 32 times 1 3/4. 1 3/4 is an improper fraction, is 7/4. I multiply across. Once I multiply across, I get 224/4. I convert that into this division problem right here. 224 divided by 4 is 56. So there were 56 celery pieces. Last one. Referring to this same casserole, I suppose. The casserole takes 1 1/5 hours to cook. It has already cooked 5/6 of, keyword, the time. How long, measuring in hours, has it cooked? So we're saying we went 5/6 of 1 1/5 hours. We went around the fraction here and converted it into 6/5. We simplified the same way we did up here, where we ended up just having 1 first, 1 times 1/1 equals 1/1, which equals 1. So it's cooked for 1 full hour. You also might have been able to figure this out because it cooked 5/6 of the time, so it almost cooked the whole time, because 6/6 means that it would have cooked the full time that it needed to. So 1 hour is very close to 1 1/5 hours. That's another way to know your answer is reasonable. Thanks for tuning in. Hope your learning at home is going well. Until next time, I hope we don't have any more ridiculous questions like number of carrot pieces in casseroles, but hey, math is math and it's important. See you next time.